In 2004, NASA scientists stared at their screens in disbelief. What they were seeing shouldn't exist. This image would challenge everything we thought we knew about our solar system. Today, we're diving into actual NASA images that left even the world's top scientists confused. These aren't conspiracy theories or clickbait. These are real phenomena that push the boundaries of human understanding. If you're fascinated by space mysteries backed by real science, you're in the right place. Hit subscribe. We're just getting started. NASA doesn't just point cameras at space and hope for the best. Every image comes from decades of engineering. Telescopes orbiting Earth, probes traveling billions of miles, rovers analyzing alien soil. And behind every lens, there are scientists with expectations. Models built on physics we've tested thousands of times. Predictions about what we should see based on everything we know about how the universe works. So when something appears that doesn't fit those models, when data contradicts decades of research, that's when things get interesting, because confusion isn't failure in science. It's an invitation. We'll explore 5 images that genuinely puzzled NASA's best minds. Structures on Mars that defied geological explanation. Formations that shouldn't exist on a dead planet. Saturn's hexagon, a perfect geometric storm that violates the laws of fluid dynamics. The heart of Pluto, revealing a world that had no right to be alive. The pillars of creation, hiding a dark secret about their own existence. And a signal from space that made scientists question everything we assume about our place in the cosmos. Let's start with Mars. In 2015, the Curiosity rover was doing what it does best, rolling across the Martian surface, analyzing rocks, sending images back to Earth. Then this image appeared on scientists' screens. Look closely at these formations. They look like tubes. Glass tubes, specifically. Translucent, hollow structures emerging from the Martian soil. And immediately, geologists had a problem. Mars is a cold, dry desert. No active volcanoes. No recent meteor impacts in this region. But these structures, they looked exactly like what you'd see if intense heat had melted rock into glass, or if molten material had flowed and solidified. The thing is, Mars doesn't have the conditions to create formations like these. Not anymore. Not for billions of years. So what were they looking at? Natural erosion playing tricks? Ancient volcanic activity? Or something else entirely? The scientific community was divided. Curiosity's spectrometers went to work, analyzing the chemical composition. Scientists compared these formations to similar structures on Earth. Lava tubes, fulgurites created by lightning strikes, mineral veins exposed by erosion. Computer models simulated Martian geological processes over millions of years. Planetary geologists debated competing hypotheses. Some argued for selective erosion, where softer rock layers wear away, leaving harder mineral veins behind. Others pushed for evidence of ancient volcanic activity we hadn't detected yet. Even citizen scientists joined in, analyzing the publicly available images, offering theories, challenging assumptions. This is how planetary science works. Collaborative confusion leading to clarity. The current consensus? Most likely, these are mineral veins, resistant to erosion while surrounding layers wore away over eons, leaving tube-like structures behind. But here's what still puzzles scientists: the exact composition, the precise age. How common these formations really are across Mars. What this taught us? Mars had a far more complex geological history than we imagined, and we're still learning. But Mars was just the beginning. From 2004 to 2017, the Cassini spacecraft orbited Saturn, sending back thousands of images. And in 2006, it captured something at Saturn's North Pole that made physicists question reality: a perfect hexagon. Not roughly hexagonal, not hexagonish. A geometrically perfect 6-sided shape, larger than 2 Earths, made entirely of swirling clouds and storms. Nature doesn't do this. Here's the problem. When natural forces create patterns in fluids and gases, they make circles, spirals, ovals. Physics favors curves. Hexagons require straight edges, precise angles, mathematical symmetry. And Saturn, it's a gas giant. No solid surface to mold or shape anything, just hydrogen and helium swirling endlessly. Yet this hexagon had been there since the Voyager flyby in 1981, decades without changing, rotating with the planet like it was painted on. It violated everything scientists understood about atmospheric dynamics. There was no theoretical framework to explain it. Scientists built rotating tanks in laboratories, filling them with fluids moving at different speeds, trying to recreate the conditions. Computer simulations modeled Saturn's jet streams, rivers of wind racing around the planet at different velocities. And then, breakthrough. They discovered that when fluids rotate at significantly different speeds, they can create polygonal standing waves. The physics was hiding in plain sight. Rossby waves, the same phenomenon that creates meandering patterns in Earth's jet stream. Cassini mapped the hexagon in multiple wavelengths, revealing its three-dimensional structure extending deep into Saturn's atmosphere. It wasn't magic. It was physics operating at a scale we'd never witnessed before. The hexagon is a massive standing wave, the result of jet streams moving at different speeds, creating a stable pattern through fluid dynamics we're still working to fully understand. It's not supernatural, but it is extraordinary what it taught us. Planetary atmospheres are far stranger and more complex than our models predicted. And sometimes, the impossible is just physics we haven't learned yet. If Saturn challenged our understanding of atmospheres, Pluto was about to rewrite planetary science entirely. July 14, 2015. After 9 years crossing the solar system, NASA's New Horizons spacecraft finally reached Pluto. And when the first high-resolution image came back, scientists saw something that shouldn't be there. A bright, heart-shaped region on the surface, smooth, pristine, beautiful, and absolutely, fundamentally wrong. Pluto sits nearly 4 billion miles from the Sun. It's a dwarf planet, small, frozen, essentially dead. It should be a cratered, ancient ball of ice that hasn't changed in billions of years. But that heart, completely smooth, no impact craters, none. In planetary science, no craters means one thing. The surface is young, geologically active. Something is renewing it, erasing the scars of asteroid impacts. On a frozen world with almost no energy from the Sun, with no right to have geological activity, Pluto was alive. New Horizons instruments analyzed the composition. The heart, officially named Tombaugh Regio, was covered in nitrogen ice, with methane and carbon monoxide mixed in. Scientists built thermal models. Could Pluto have enough internal heat left over from its formation? What about radioactive decay in its core? Models suggested a subsurface ocean of liquid water might exist beneath the ice. Then they discovered the mechanism. The nitrogen ice wasn't static. It was convecting, like a lava lamp. Warmer ice rising, cooler ice sinking, constantly resurfacing the plane. And mountains made of water ice floating on denser nitrogen. Cryovolcanism, ice volcanoes. On Pluto, Pluto is geologically active through processes we call cryogenic, cold versions of volcanic activity. Nitrogen ice convection renews the surface. A possible subsurface ocean stays liquid through radioactive decay and tidal heating. Pluto isn't dead. It's thriving in ways we never imagined possible. What changed? Our definition of what makes a world alive in the solar system. But some mysteries aren't about what we see. They're about what we're not seeing yet. In 1995, the Hubble Space Telescope captured one of the most iconic images in history, the Pillars of Creation, towering columns of gas and dust in the Eagle Nebula, where new stars are born. Then in 2014, Hubble looked again, this time in infrared light, and revealed something devastating. Infrared light penetrates dust that visible light cannot. And inside those majestic pillars, young stars, already formed, already shining. But that wasn't the shocking part. Scientists detected evidence of a shockwave from an ancient supernova racing through the nebula. They calculated its speed, its trajectory, when it would have hit the pillars 6,000 years ago. The pillars are 7,000 light years away. We're seeing light that left them 7,000 years ago, which means we might be looking at ghosts, structures that no longer exist. Different wavelengths of light tell different stories. Visible light shows us the outer clouds, beautiful and serene. Infrared reveals the violent stellar nursery within. X-rays from the Chandra telescope showed the aftermath of supernova nearby. Scientists analyzed the shockwave's velocity, traveling at millions of miles per hour through space. They modeled how long it would take to reach the pillars, how quickly it would destroy them. The math was clear. If the shockwave hit 6,000 years ago, the pillars were likely vaporized millennia ago. But we won't see their destruction for another 1,000 years. The light showing their end hasn't reached us yet. The pillars of creation probably don't exist anymore. They were destroyed by a supernova shockwave 6,000 years ago. But we're still seeing them because light takes time to travel. Every astronomical image is a photograph of the past. We don't just study space, we study time itself. That's the profound lesson. In astronomy, everything is archaeology. But perhaps the most haunting mystery isn't what we saw, it's what we heard, once and never again. August 15, 1977. The Big Ear Radio Telescope in Ohio was scanning the sky, listening for signals from space. Dr. Jerry Emmon was reviewing the computer printout of that night's data when he saw something that made him grab a red pen. 72 seconds of the impossible. The signal's intensity was 30 times stronger than Mauses. Its frequency 1420 MHz in line. Hydrogen is the most abundant element in the universe, and 1420 MHz is the natural frequency hydrogen emits. If any civilization wanted to broadcast a signal that others might recognize, this would be the universal channel. The signal came from the direction of Sagittarius. It was narrowband, extremely focused, not the kind of broad-spectrum noise natural phenomena create. Emmon wrote one word in the margin: wow. The signal never repeated. For decades, astronomers have pointed telescopes back at that same patch of sky. Nothing. Silence. They investigated every possible terrestrial source. Satellites, aircraft, ground interference. All ruled out the signal came from space. In 2017, astronomer Antonio Paffa proposed que 266 P. Christensen was passing through that region. Maybe it released hydrogen gas that created the signal. But other scientists pushed back. Comets don't emit narrowband signals like that. The frequencies don't match. Modern radio telescopes, far more sensitive than Big Ear, continue monitoring the region. SETI keeps searching. The debate continues. Natural phenomenon we don't understand, or something else entirely. We still don't know what caused the wow. Signal. The comet theory remains controversial. No natural explanation has been definitively confirmed. It sits in our data as an unexplained anomaly. Maybe it was a rare astronomical event. Maybe interference we couldn't identify. Maybe something we weren't ready to find. The truth, we're still listening, still searching, still wondering. 5 images, 5 mysteries. Each one pushed science forward in unexpected ways. Glass tubes on Mars teaching us about ancient geology. A hexagon on Saturn revealing physics at planetary scales. Pluto's heart showing us that small worlds can stay alive. The pillars of creation reminding us we're always looking at the past. And a signal from space that we still can't explain. Here's what connects them all. Confusion isn't the enemy of science. It's the catalyst. Every puzzled scientist standing at their monitor, staring at impossible data, is standing at the threshold of discovery. Right now, at this very moment, NASA telescopes are capturing images we haven't seen yet. Rovers are analyzing rocks on distant worlds. Radio telescopes are listening to the cosmos. Some of those images will confirm what we already know, but others will make scientists stop, lean forward, and whisper, "That's not possible." And that's when the real work begins. That's when we learn something new about our universe. Which of these mysteries fascinated you most? The ancient structures on Mars, Saturn's impossible geometry. Let me know in the comments. I read every single one. If you want more space mysteries backed by real science, no sensationalism, just genuine wonder at what's out there, subscribe and hit that notification bell. Next week, we're exploring the strangest moons in our solar system. And trust me, they're weirder than you think. Thanks for watching, and keep looking up.